Yeah, I am live. Let's go live here. Yeah, I am live there. Yeah, so we are there live, and let's see people pouring in, and we will be able to handle the stuff of exact differential equation. Let us see. Yeah, okay, fine. So I believe people will join in soon, and we will be able to go through the whole process as we do. And let us start with the main portion of live lecture. Let me now start what is see uh, eg- regarding differential equations. We already have a big, you know, elephant in the room of mathematics, that differential equations, okay, when you want to study them in mathematics, it is not a very straightforward topic. There are various methods that are there which classify the class of differential equations. So you can imagine it's a big field in which there are plenty of equations, different types of equations are there, and then you start classifying them. So in one such classifications of differential equation, there is one small type called exact differential equation. That is what we are dealing with now. Exact differential equations, okay. Okay, now it's a very small type in which we are going to see it, some more different types after, like today, after today's lecture also there are gonna be more types too. But exact differential equation is one small class of equation. Like if you have joined, just put hi or something so that my voice is visible, my voice is audible rather, and I am visible to you. So ऐसा कुछ है कोई, you, those who are there, you can put hi in the chat box, and we can you know, have a discussion also, like you can speak. Okay, now what we are gonna do in differential equation, basically we are going to go from exam point of view also, and I would also like to show you how these differential equations are more or less related to the phenomenon across the physics and everything else also. But for time being, as we are we are starting to deal with differential equations, we will first see what is exact differential equation. So let us see the main definition here. I'll just put a different color here. So main definition is, so the first main definition here we have is, we say there that let a differential equation let a differential equation of the form mx comma y dx plus nx comma y dy equals to 0 be given. We call this 1 be given. Then it is called an exact differential equation if it is called an exact differential equation if, other here it is if daba m by daba y is equals to daba n by daba x. This is what it is. Now what do we have out of this is, like whenever we have a differential equation we have its solution also with it. So what do we mean by the solution? Let us see the formula over here. For every differential equation there is a kind of a solution we have. Okay, so let us see the first kind over here is here, that we'll call this first equation number 2, and then let us see what happens here. The general solution of equation number 1 of an exact DE is given by, there are two formulas here. Now you can remember either one of the two. Now I'll tell you why there are two formulas and when to use the one which you the other one above the other. So let us see. So given by number 1 integral mx comma y dx. Here there is a condition that y should be constant. Okay, treating y constant, plus then there is something terms of n x comma y free from sorry free from x, okay, dy equals to c. This is the first formula that you have. Now there is one more version of this. Okay, so or there is, you just have to swap the term. So I'll write this in white. Terms of m x comma y free from y dx plus terms of we have written terms of mx comma y free from y dx. Here you have n x comma y dy where x is constant. This is alternate version of the same. Now there are some questions are there sometimes where what we have is uh, some kinds the first method works for the solution easily, sometimes second method is not easy. Sometimes the first formula will work, sometimes the second formula will work, something like that. Now let me tell you here that in order to solve the exact differential equation, there are 2 to 3 methods available already by various authors in the world of mathematics. So we shall be using the most standard and the most easiest of all, because there are the other methods, uh, they look very fancy and very mathematically intuitive, but the difficulty in them is that the calculation procedure, anywhere anyway the calculations are going to be difficult, there is no doubt, but as compared to the method that we are choosing, the other methods are already lengthy and difficult in nature, so we won't go for those methods. We would stick to the standard methods that are uh, going to be adopted by most of the uh, teachers who teach exact differential equations. Okay, now differential equation in short we shall be calling DE throughout, and let us see some questions regarding them. Now let me take up some simple and easy question so that you resonate with the definition and you have something to speak about it. Now see, whenever a differential equation is given to you, they generally give this way: solve. They don't even tell you that the differential equation is exact, homogeneous, non-homogeneous. They just give you plain thing: solve the following differential equation. That is also too much. They will just say solve. Okay, they just say solve, nothing more they give to you. Now let us see how to handle this. um, yeah, x minus 2e to the power y dy plus y plus x sine x, okay, dx equals to 0. Now this is the question that we take up. Now this is the first question and there is a twist in the first question itself, so let us understand it carefully. यहाँ पे एकदम ध्यान से देखेंगे कैसे करना है इसको. So firstly, our format of the differential equation was m dx plus n dy, right? So we write here comparing. First we will write the thing, first we write the dx and then we go for the main part. So given dE is y plus x sine x, we write the dx portion first, okay, and then we go for the other one, the dy part. Now we compare compare with mx comma y dx plus nx comma y dy equals to 0. When we compare, what do we get? We get is here, that is, therefore mx comma y is y plus x sine x, and n x comma y is x minus 2 e to the power y. So the moment we take dabba m by dabba y, sorry, I have got a bit cough. um, the moment we take dabba m by dabba y, we get over here the answer uh, for the partial derivative. So now when you do the partial derivative, remember that the variable with which the integration is going to happen is given at the bottom. Okay, so here we are integrating with y, so x is going to be treated as constant, so your answer is 1. Okay, derivative of y is 1, x sin x is constant, so its derivative is 0, and dabba n by dabba x, so here also it is 1, so therefore dabba m by dabba y is equals to dabba n by dabba x. So we have now got a nice claim to say that therefore equation 1 is an exact DE. Okay, now we go for writing the solution. Therefore general solution of 1 is integral. Now till the time you do not feel comfortable with the second version, you stick to the first version of the formula, so it is m dx plus terms of n free from x dy equals to c. So this is a formula. Now we integrate this, we write the formula here, we have already written, but now we write the solution. So what will be the solution for this? So solution will be integral y constant. You do mention that y is constant, okay, so you here you can mention that y is constant, so integration where y is constant, right? So y, you have sine x, right? Y x sine x dx plus terms of n which are free from x. Now which are the terms in n which are free from x? That is, those terms we have to take with the signature. So here I can clearly see that the terms that are free from x are this minus 2 e raised to y, that is free from x. So here we write the term that will be minus 2 e raised to y, okay, dy, that will be there, dy equals to 0. Now we integrate here, so y is constant. Now y is constant, so y treated outside, integration of constant is the variable, then so variable is x. Now when you integrate x sine x, how do we integrate? In UV rule we will have to go, so it is x integration of x, wait a minute, here, yeah. So now when we are integrating, it is x integration, then we go for sine. Alright, so now integration of sine is going to be minus of cos, because, right, so it is minus of cos of x, then there is minus sine x derivative is 1, and here minus cos x integration, if we do, it is going to be minus of sine of x. Okay, that's the integration. And then here you have minus 2 e raised to y, you are integrating, so it is minus 2 e raised to y is, yeah. And here one thing I forgot, that it is not 0, it is c. Here you write c as a constant of integration. Okay, I think here, here we have written c. Okay. Okay. E raised to y, and this is c. So therefore xy is minus x cos x plus sine x minus 2 e raised to y equals to c. This is the solution. So we, after this we write here is the required general solution of 1. This is what is there. Now we go for the next kind of a question, so that we build our confidence on this, and then we can handle any kind of the equations which are there. So let us see how to go about this. Let us do this one, which is kind of very simpler in nature, not a trigonometric question. So we'll take up this. Question 2 is solve for x square minus 4xy minus 2y square dx plus y square minus 4xy minus 2x square dy. Now see, this kind of questions, when they come to you in the examination, you have two methods to be done. Okay, you can do, see, these are homogeneous equations. Okay, this one is a homogeneous equation. You can do two ways, whichever way you like, it is going to give you the answer. Both the ways are correct. Okay, I am now going to do the method 1 for exact differential equations, because we are doing that topic. But if any student who gets it done by homogeneous, I don't think so on any mathematical grounds he or she should be given wrong, because this is a homogeneous equation and it is the method if the student does it correct. So not a big issue on that. Okay, so now let us see how to go about it. X square minus 4xy minus 2y square. So we compare and we write, so comparing with m dx plus n dy equals to 0, we get m is x square minus 4 xy minus 2y square, and n is y square minus 4xy minus 2x square. Now we go for verifying the condition. Dabba m by dabba y is equals to, now when you take the derivative, x square derivative is 0, minus 4xy derivative with respect to y is minus 4x, and here it is minus 4y. And what about this one? With n it is 2, what it will give you, dabba n by dabba x. When you do the derivative, y square derivative is 0, minus here it is 4y, and here it is minus of 4x. So therefore you have here dabba m by dabba y is equals to minus of 4x minus of 4y, and here it is dabba n by dabba x is equals to minus of 4x minus of 4y, and hence they are equal. So dabba m by dabba y is equal to dabba n by dabba x. So anytime you get this condition equal, you are expected to say that it is the given differential equation is exact. बोल देने का exact है. तो अभी यहाँ से, so you label this equation as number 1, the given question. Do write the given question again in your answer first, and then start writing your answer. Very important. So therefore equation 1 is an an exact DE. Okay. So this is an exact DE. Now we go for finding the solution. So therefore the general solution of 1 is given by, now I can use any formula of my choice. So for this one I am going to use the second version, not a big problem. So let us use that. Therefore is given by, you can use any of the two, whichever you find comfortable. I am okay with both the formulas, so I am here now writing the second version. Terms of n, just a minute, terms of m free from y dx integral x constant you have here n dy equals to c. Now what are the terms? Let us see. So m we had already there, so free from y, so only term free from y is x square, right? X square is the only term which is free from y, so here you have x square dx. Okay, and you have to take entire n, so it is n y square minus 4xy minus 2x square dy equal to c. So therefore x cube by 3 you get here, right? And here now you are going to integrate treating x constant. So y is the variable you are integrating, so y cube by 3. Okay, and then there is 4x which is there, you can see that is going to be treated as constant, y square by 2, and here it is going to give us 2x square, don't integrate 2x square, you have to keep it as constant, so here it will be y. Okay, so because x is constant, right? So all functions of x are treated constant, so you get that. Now this is equals to c, so therefore final answer is x cube plus y cube over 3 minus 2xy square minus 2x square y equals to c. This is the answer. Or you can even multiply this 3 all throughout and write it as in terms of 6 also. Both are one and the same. So is the general solution of 1. Okay, this is what we get now. Now we will see another kind of a differential equation which is slightly tough in nature, and that will, that really bothers us in original solving. Sorry. Now let us take up some questions which are really tough looking in nature, but then you can solve them quite easily. Now these are some pretty lengthy stuff are there, but then we can do it. Let us see how to handle them. First question we'll take up this one. That is sine x cos y plus e raised to 2x dx plus cos x sin y plus tan y dy equals to 0. So here we just write always this. You again write the question in your answer, and then what you will get is m is sine x cos y plus e raised to 2x, and n is cos x sin y plus tan y. Okay, now dabba m by dabba x, dabba m by dabba y we will do. So we get here, what do we get? Dabba m by dabba y, sin x is constant, cos y derivative is minus of sin y, and e raised to 2x is 0, right, when you do the derivative with y. So finally you have minus of sin x sin y here, and here what do we get? Dabba n by dabba x when we have to do, so derivative of cos x is minus sin x, and here it is sin y, derivative of tan y is 0, okay, with respect to x. So here therefore we say that dabba m by dabba y is dabba n by dabba x. So we do this, and we will be then seeing how to write the solution. How do we write the solution for this? So you first write here that therefore 1 is an exact DE. So what do we get here is what do we get here is general solution is integral d dx y constant plus terms of n. Here you can write n free from, rather it is terms, okay, not n, terms of n free from x. When you write dy equals to c, so when all this is happening, what do we get here? On integration, let us see. Therefore integration sin x cos y plus e raised to 2x, okay, y is constant, and here we are integrating with respect to dx. Okay, we'll integrate with respect to we are dx, and then terms of n free from x they are saying, so only term that is free from x is tan y dy equals to c. Now when we are integrating, cos y is a constant, so it will come outside, therefore cos y. Now integration of sin x, so derivative of cos x is going to give you minus of sin x, so integration of sin x is minus of cos x over here, and then you are integrating e raised to 2x, so e raised to 2x by 2. Now tan y, many children make this mistake, so here you will have that, see this, if you don't remember this formula integration of tan y, you can even recall some another formula which is f dash. I'll give you that formula, but here for time being you can take here, the answer is log of sec y, okay, log of sec y is your answer, and yeah, log of sec y equals to c. So this is the thing, so therefore minus of cos x cos y plus e raised to 2x over 2, and you can have this plus log sec y plus equals to c. This is your answer, okay, and you can shift that minus sign this side or other side, that's not a big issue. Okay, so I hope you have got this. There is nothing much to solve on this part, but then that's, even if you have not written the last part, then that is the final. Now let me tell you how this tan you should remember, how to remember integration tan y. Many children forget this, or integration of tan of y, or tan x, whatever, anything, it doesn't matter. See, integration tan of x is nothing but tan x with dx, it's nothing but tan is nothing but sin x over cos x, okay. We have done this one very important formula, integration of f dash of x over f of x dx is log of fx, okay. So so derivative of cos x is minus sin x, so you have this minus of minus sin x dx over cos x. So this is nothing but minus of log of cos x. Okay, and this will minus sign goes inside, it gives you log of sec x. So that is why we got integration of tan y is sec y. So this derivation, I believe everybody by +2 level of your education should be comfortable, otherwise it's a tough time that you will face with derivatives and integration throughout. Okay, so this was the question that we did. Now let me take up another question in which terms are slightly different than the regular ones that you see. Yeah, let us do this kind of question, that is, now one very popular question I would like to take, that this one comes, it has come in several exams, and several number of times people have done this, but you know, it's a very nice question, otherwise you can try this on your own also. um, I'll give you that to try, but let me give you some question which charges you up with some enthu. It's a very long question. Y sine xy plus xy square cos xy, okay, dx plus x sine xy plus x square y cos xy dy dy equals to 0. Now there is one type going to come related to this, but then we will see it later on in that type also, how to solve similar questions like this, but for time being we will solve this one with the knowledge that we have. Now when we do this, this question can be done in different ways also, so let us see how does it work. M over here is y sine xy plus xy square cos xy, okay, and n over here is x sine xy plus x square y cos xy. So when you calculate dabba m by dabba y, what it is going to give you, so you will have UV rule coming all throughout, right? So y into sine derivative is cos xy into the derivative of the angle, so x is the derivative, okay, and then there is sine xy remaining outside, and there is y derivative is 1. Okay, now then there is x y square remaining outside, and cos derivative of cosine is minus of sine xy into x, okay, that is what you will get, and then there is cos xy times derivative of xy square. What is derivative of xy square with respect to y? It is going to be 2xy. Okay, now let us see whether dabba n by dabba x comes equal. So we have here x sine y. So x sine y, when you do the derivative, what you get? We'll get here x sine derivative is cos of xy into y, and then there is cos xy, right? That's what we have. No, wait a minute. We had sine there, right? So here we will have sine. So sine xy, yeah, and x derivative is 1. Okay. Now what about the other part? When we take your derivative, y is treated outside. It's a constant. Oh, so y, you can keep x square by constant, and cos xy derivative is minus of sine xy into y. Okay, that is there. And then we will have here plus cos xy remaining outside, and x square y derivative, when you do with respect to x, it is 2xy. Now let us see whether the terms are matching or not. Okay, we have smileys coming. Fine, thank you. So you can put your views in the chat, like if you are feeling very drowsy or something, then let me know, because there are going to be various several problems are there on which you can brood upon, and they are going to help you to motivate to think more and more differential equations. Okay, so if you have any difficulty, let me know in the chat section. So yeah, now you see almost every terms are same, right? All terms are same, just a bit more understanding is required. That see this term is same, then here we have this term same with this one. Now this term is also same. Okay, and then I can say that this term, the wave term that I'm drawing, is same. So essentially we have this as same, therefore dabba m by dabba y is same as dabba n by dabba x. So we write the general solution. General solution for this, sorry, I'm down with cough. I'm extremely sorry, but I had scheduled this, so I said show must go on. So let me complete that stuff so that people lying out there can benefit from whatever stuff we can provide them online in this lecture. It is very important that you get the hold of the concept. Okay, so I thought I'll continue with the lecture, that would be better. So here we have general solution y constant m dx plus terms of n free from x dy equal to c. Now what are the terms free from x? There are no terms free from x. Okay, so there is no terms in n that are free from x. They all are multiplied with x, so they are all there. So n terms are going to be 0. Okay, so terms for n here, they are 0, dy equals to c. Okay, and here m what is there, that is y. With y we are going to treat it as constant, so y sine xy, and then we have plus x y square cos of xy, and here it is y is constant with dx. Okay, so when we are integrating here, it is with dx. So let us see how to go about it. So what do we do here is this, um, y is constant, derivative of sine xy, sorry, integration of sine xy is minus of cos of xy divided by the angle, so the constant which is there. So we are integrating with respect to x, and y is constant, so it be divided by y. Okay, and then here again we see that y square is constant, and here we have to integrate x cos xy, treating y constant with dx. Okay, so while doing this, this and this y gets cancelled, minus of cos xy, and this y square. So when we integrate over here, x cos y, what is x cos y integration? That is what we have to remember now. Now we will use UV rule. So UV rule here is x as it is, integration of cosine is sine xy. Now y is constant, so we treat y in the denominator as a derivative when we take dxy, xy derivative with respect to x, so y is constant, minus what will happen, x in derivative is 1, and we integrate here again, so sine xy integration is minus of cos xy over y square we will get. Okay, sine xy over y. Sorry. um, this is c, so minus cos xy. Now this is xy sine xy, minus and minus makes it plus, y square is gone, so cos xy okay, and it is c, and this, yeah. So we see that here again this term is getting cancelled. Okay, so what do we do now? So we get our final answer. So therefore my final answer is xy sine xy is equals to c. This is the answer for uh, the differential equation. Okay, so is the general solution is gs of 1. So I hope you have followed this, and you will be able to solve any kind of questions related to exact differential equation. I have shown you 3 questions. Some are trigonometry, some are exponential, mix, and one is algebraic, and I hope this works for you. And if any difficulty is there in the entire concept, let me know. I would be happy to help you on this, and we will now see. You can practice these examples. They are very popular examples asked across various examinations in various different universities. So you can solve them, solve the following the E which are using exact, okay, which are exact. So you have to actually check them exact and then do, but in exam you will get solve the following DE, nothing more. Okay, so or rather you will just get solve, nothing extra won't be given to you in exam. So can you try this? It would be very good for you to practice the following on your own. That let's see this. These are very standard questions. That is x root of x square plus y square minus y dx plus y times square root of x square plus y square minus x dy. Okay, dx dy equals to 0. Now can you see they are almost running symmetric in nature, so that is what is there. And question number 2, you can try this. I said I'll give you a popular question, so let me show you which is this. Extremely popular, very famous, dear to most of the teachers. Solve dy y cos x plus sin y plus y divided by sin x plus x cos y plus x is equals to 0. These are some extremely popular questions. You can try this one also. This is also a good question. So y over x square cos y by x dx minus 1 over x cos y by x dy plus 2x dx equals to 0. Okay, so I hope these 3 questions along with the 3 that we have done, so totally 6 questions, will solve your difficulty on exact differential equation. If you have any difficulties, let me know in the comment section. I'll be happy to help you on this. Yeah, what which PDF would you like to have? Could you please tell me what PDF would you like to have? Like, I don't know what is he talking about. You want the PDF of the PPT that I have done, or for that you need to contact me on my email. I don't know. Like, can you tell me what is the difficulty you have? Have you followed it? Do let me know. Like, was it easy or was it difficult? Yeah, I would like to tell you one technique which is extremely powerful technique of integration that I had encountered. If Please do share this thing with your friends. It's very powerful way of getting integration answers. UV rule. This is actually, I have named this as general UV rule. Okay, but it is not a general UV rule. It is called the reduction formula. Okay, it is basically a reduction formula for some case. Reduction formula it is called, but let me show you what happens. See, we will need to do this thing first. Let me tell you, this is very important. this rule will save your time, this will save your energy. You will not need too much of thinking after this, because this rule is time saving. Suppose you want to integrate something related to like integration x raised to 4 into cos 3x. Okay, it's a big term, like UV rule. If you want to go about, huh, you will have to integrate it. Inside integration there will be integration, again integration and integration, it will go on. That process is very lengthy. Yeah, right. Within UV rule, it will go on coming till the time the power doesn't collapse. So, or some another question, if I take say x square into sine x, sine 2x, again similar thing you have to do. Similarly, if you have something x raised to 3 into e raised to 4x, again you will have to do UV rule again and again. So in such a case, what we have to do, if all this is there, then for the last three terms, light, algebraic term, do you remember what is light? L for light is, L is logarithm, I is inverse, okay, A is trigo, sorry, A is algebraic, and algebraic I'll write here, T is trigo, and E is expo. Okay, so like the last three terms, if there is a combination of last three functions, I mean to say algebra is combined with trigo, algebra is combined with exponential, then in such a case there is a sweet nice formula that says something like this. Let me help you with an example. What you need to do is this, like let me take up an example, integration. So first step is step number 1. You arrange everything in Layet order. Okay, arrange everything in Layet order. LIATE. So ATE we are focusing. So if you are having some question like say x cube into sine 3x, let me take some different number so you can get that. I'll take something like, let's say integration x cube into cos, yeah, let's take cos 4x dx. Okay, how do you integrate this kind of thing within one line? This is very helpful technique, and let us see how to do it. So the formula says you put x cube as it is first, no change, keep x cube down without any change, okay, in the answer. Now for cos, you integrate cos. So on integration of cos, what do we get? We will get integration of cos is sine 4x by 4. Okay, now then by formula there is a minus sign. That blue color sign is by formula. Now what you do is take the derivative of x cube. So it is 3x square. The next one is the orange bracket that you had already got the integration. You integrate it again without any simplification, right? I mean to say, if there are any plus minus signs in between, don't simplify them. So sine 4x upon 4, what is the integration of that? It is going to be minus of cos 4x over 4 square. Okay, Okay, now you will feel this minus and minus, the blue minus will become plus. No, don't do any simplification in between. So what I'll do now, after this there is a plus sign after the thing. Okay, we have once used minus, then we use now plus. So 3x square, after this you will have uh, we will go for 6x. Take the derivative of 3x square again. Okay, so you get 6x. So minus of cos 4x upon 4 square. What is the integration here? The integration is minus of sine 4x over 4 cube. Okay, this is the integration. And then there is one technique here again. Then after this plus there is minus sign, and then take the derivative of 6x. So derivative of 6x is 6, and again the orange bracket will come back. So when you have the integration, so minus of sine 4x upon 4 cube, the integration of this is going to be, sine integration is minus of cos, so minus minus makes it plus, so cos of 4x over 4 raised to 4. Now you can do the simplification of those minus and pluses, etc., and if any terms are getting cancelled, then you can cancel. So what do you need to remember is, whenever you want to do the general UV rule, the main important thing is that you take the derivative of the first term you bring it as it is, go on taking d by dx derivative you take, and for the orange bracket you take the integration. Okay, go on taking integration, do not change the format of the orange bracket in between, don't simplify it at all, otherwise this 6 and 4 cube you will do some cancellation, it won't give you the correct answer. So do the integration very carefully, don't even put this minus and minus make it plus, no, don't change any sign in between at the end. So this process will stop after some time, because algebraic function derivatives are going to vanish soon. So x cube, 3x square, 6x and 6, after 6 the derivative is 0, so we stop. So here you do this technique and you will get your answer. Okay, so this is the reduction formula for um, general or the general UV rule, generalization, not exact generalization but a kind of. Okay, so this is what I wanted to tell you. This serves a great purpose in most of the integrations in engineering. If you remember this rule, I believe it is very easy for most of the people to handle. So till then, thank you. This was it on my side. If you have any doubt and difficulties, please let me know in the comment section. So we shall stop now for the day, and thank you for joining in, and please hit like and share this video with your friends, so that they benefit a maximum from the videos, and if they are stuck up in any kind of work, I'm sure the recording will help them. And thank you for joining in. So we shall stop, and please hit like or do comment your views in the comment section. I would be happy to read your comments. Okay, so for time being I think very few people are there, so no worries. We will see you soon. Okay, We will meet soon again. Tomorrow we are meeting for the second part of the exact differential equations, which is I'll be dealing with the non-exact one. So stay tuned, watch my next video, and I'll soon see you there on live. Thank you.